What we advocate for in this paper is trying to target a controlled direct effect as a way of accounting for expectancy in a manner that we think gets at the root or the heart of the placebo effect problem, the functional unmasking problem, insofar as we think this will put the drugs on an even playing field.
I'm Eric, and this is Research Notes. In this episode, I talked with Dr. Gabe Loewinger. He's a research scientist at the National Institute for Mental Health. He studies causal inference methods for chemical dependence and neuroscience-related studies. I first learned of Gabe and his work when I read a paper where he and colleagues proposed what they were calling the controlled direct effect. And they apply it in trials of things like psychedelics, where you have functional unblinding, where people can pretty much guess which arm they've been assigned to. And in these types of trials, a common approach is to consider how to control for people's belief in which arm that they've been assigned to, or their expectancy of what the treatment might do for them. Gabe argues in that paper and in our conversation that this approach of controlling for post-treatment variables actually is controlling for a collider, and you can make things worse when you do that. He argues instead to think about them as mediators. So we talk about his DAG and his paper, and I hope you enjoy this conversation.
I'm a psychologist, recovering clinical psychologist, but I have not done any work in psychedelics. And I read about this Compass Pathways trial. A very interesting challenge in trials of psychedelics where you know if you're in the treatment group and you know if you're in the control group, right? So they talk about this idea of functional unblinding, and some of the strategies for dealing with is like having an active comparator and using dose response designs. There's also the idea of trying to measure people's knowledge or guess at which arm they were in and measure their expectancy. There's some issues with that, though. You have an interesting paper that talks about not this particular trial, but trials of psychedelics and unwinding. Talk us through it. What's your approach to how we should think about measuring this?
So in the paper, we argue that dealing with placebo-like effects in these trials, thoughtfully incorporating post-treatment expectancies or hopes into your analyses, because a lot of intuitive approaches, like including measurements of what treatment you think you got, which we call belief, into an analysis, like throwing it in a regression or looking at treatment effects within people who think they got the drug or didn't, stratifying on it, introduces some biases into the analysis. So this is famously known as collider bias in the causal inference literature. And even if one were able to solve the problem of tricking people so that they don't know what they got, we don't think it fully resolves the problem. Because if hopes or expectancies are really driving the causal effects, the treatment effects in a meaningful way, just tricking people about what they got isn't going to get to the essence of that, the heart of that.
People's belief in that they were treated, that could be accounting for a lot of the effect you actually see and whether or not it makes them better. It could be rooted in their belief about being treated.
Part of it can be rooted in their belief, but the critical thing in our mind is that if you're concerned that people are hyped up or that they have a lot of optimism about how the drug is going to help them, just tricking them about what they got doesn't necessarily work. You can think about this problem of why expectancy is really critical in these cases over belief by thinking about cases where you have what we call belief blinded. You trick people and they can't tell what they get, but their expectancy unblinded, meaning that the treatment and the control cause different expectancy levels on average across the arms.
Okay.
And you can think about the opposite. So one case that I think is helpful is to think about something where your belief unblinded, but expectancy blinded. So what does that mean? I call this the benevolent alien story. So Eric's walking home one night and he gets abducted by aliens. And these aliens say, Eric, you've been selected to be in a randomized clinical trial of 2 drugs that we believe will extend human life. We don't know which one's better, but we're going to randomize you to one of them. We'll tell you what it is, and then we're going to observe you for your life and see how long you live. So the first drug is Gestumpen, and the second one's Column. And you're like, okay, thank you. And they go to the other room, they randomize it, and they're like, okay, you've been selected to receive Gestumpen. They give you the injection, and you go about your life. And they're like, there's no side effects. You have nothing to worry about. You know what you got. Yeah. It's belief unblinded by design. But we call it expectancy blinded because there's nothing you can do with the Gestumpen or Galumpen information. They also don't know. Does that feel like they're not on even playing fields for the sake of this study? To me, it feels like they are on even playing fields, but just because you're not going to go and change your behavior or open up some sort of or other nuisance pathways because you know what you got. Conversely, you can think of in the psychedelic field, imagine you use deep blinding or active comparators. You give people two drugs. Let's say you randomize them and they're drug naive. So you give them some psychedelic, let's say LSD or psilocybin, and you compare it to some other hallucinogenic drug, like let's say salvia, that has a lot of dysphoric properties. You randomize them, you give it to both people, and you ask people, what do you think you got? They say, I have no idea. Maybe they didn't even know. You use techniques like deep blinding where they have no idea what type of drug they might even get in the trial.
I see.
But one drug leads to a lot of dysphoria and one leads to euphoria.
Okay.
So they're belief blinded, but they're expectancy unblinded. There's different expectancy levels between them. That to me feels like they're less on even playing fields, even though they're belief blinded, than the benevolent alien story.
No, that makes a lot of sense. Did y'all come up with that as a way to talk about this?
We did.
I think it should be in an appendix.
Thank you kindly.
That highlights part of the challenge here. And the FDA is talking about including measures of belief and measures of expectancy. And so the question is, what if anything, do you do with that in an analysis?
Yeah, great question. Like you said, they've called for this, but there's many ways you can incorporate into an analysis. What we advocate for in this paper is trying to target a controlled direct effect as a way of accounting for expectancy in a manner that we think gets at the root or the heart of the placebo effect problem, the functional unmasking problem, insofar as we think this will put the drugs on an even playing field. The controlled direct effect can be estimated if you get measurements of expectancy. You could do it experimentally or you could do it in an observational fashion. Let's start with the experimental approach because that then defines a target trial or a hypothetical experimental design that we could attempt to emulate if we were to use observational data. So imagine you ran a 2x2 design where in the rows you have treatment or control and in the columns you have high expectancy or low expectancy. So what do I mean by high expectancy or low expectancy? Imagine we used some sort of intervention, another type of manipulation to try and push their expectancy one way or the other. It could be hard in practice, but here are some examples that I actually got from one of the co-authors. He suggested this idea and I really like it. So this basically means you have four groups. Right? You have people who are in the treatment group and they get high expectancy, treatment group, they get low expectancy, and then you have two more groups, right? They get the placebo and high expectancy and placebo and low expectancy. Okay, what do I mean by high expectancy and low expectancy? Imagine at the time of the trial, we give you a pill that either has psilocybin or let's say some active comparator, let's say THC. And then on top of that, there's randomization of a second pill, an auxiliary drug. Okay. In reality, it's just like fish oil or it's just a sugar pill. There's never anything in it. But for the people who are randomized to receive it, they give the pill and maybe a doctor says something like, hey, we think this will augment the effect of what you get. Maybe it has antioxidant properties that facilitates the effect of the drug.
You would lead them to believe that this is going to make it more effective for them.
Exactly. And then for the folks who don't get it, you don't say anything at all. You either don't give them the pill or we probably have to like really nail it down. But this is like a potential
low expectancy, right? Walk away. Yeah,
exactly. They get whatever they get. Or maybe you're in a world where if you're randomized to low expectancy, that you actually give someone something and you're like, this isn't going to hurt you at all, but it might block some of the kind of long-term neuroplastic effects, but your trip will be the same if you get it. This is just an idea. It's just one way of offering some kind of concrete pill to try and trick them, to try and move their expectancy one way or the other.
Gotcha.
Now what you could do, now you have these four groups, right? It's randomized. You could then compare the treatment effect of psilocybin versus control among the people who are high expectancy.
Yes.
That's one causal effect. You could also look at that same causal effect among the people who treatment versus control among the low expectancy people, those two arms.
Okay. Yeah.
Both of these would be called, like in our language, these would be controlled direct effects.
Okay.
You're controlling the expectancy and you're looking at a direct effect of treatment not mediated through expectancy, because we're attempting to holding expectancy fixed experimentally.
Yeah. Yeah.
This control direct effect, we think ideally you would do it experimentally. Probably would take some work to really work out how effective that would be, what types of manipulations. But this also defines a target trial, an ideal experiment that naturally lends itself to testing the effect you want by experimentally manipulating the variables of interest, in this case, the treatment and the expectancy. This defines what you could also attempt to do with observational causal inference techniques in a standard 2-arm design where you just randomize people to either receive the control or psilocybin, the psychedelic. You would collect data about their expectancy, you would measure it instead of trying to manipulate it. And then the challenge would be having to measure all common causes of their post-treatment expectancy and their outcomes, let's say depression levels 6 months after. If you can do that, you can use modern causal inference, observational causal inference, statistical methods to try and estimate this effect that you would have gotten had you run this 2x2 experimental design we just described.
Well, we've heard examples of potential common causes that you might want to measure.
Yeah, great question. I think a natural one that people talk a lot in the literature about is your pre-treatment expectancy, like your hype. Maybe you come into the study thinking, hey, I read Michael Pollan's book, or I have talked to friends who have taken psychedelics, and I hear that this is going to solve all my problems. Or maybe you're part of a community that has very little exposure to it, and you're like, oh, that's hippie stuff. That could hurt you. That could fry your brain. Maybe you just don't know anything about it. So we call this hype, but what we really mean is just pre-treatment expectancies.
I think a lot of people aren't familiar with the target trial approach, which is a really nice framework for doing that thought experiment before proceeding with the observational study that you might have to do, because you can randomize people to expectancy.
Yeah, I think that's right. I like it because it forces the statistician or the people who are designing or identifying the causal effect are really interested in targeting a causal quantity, a treatment effect that could be estimated in a reasonable experiment. There are many kind of causal effects out there that feel intuitive and are interesting, but could never be estimated from a real experiment. There's some debate about these topics in the causal inference field, but an intuitive example is the natural direct effect, which is another type of mediation quantity. And some people might think this is a nice solution for this problem. From our view, you're better off targeting causal effects that are framed entirely around an experiment that you could run, even if it's not necessarily feasible to do it at the time of the trial for ethical reasons or maybe just pragmatic reasons, right? Like maybe this kind of expectancy manipulation idea we came up with wouldn't work in practice. But at least you can define it and say, this is like really what we're going after.
You have in your paper a nice DAG to show your thinking about what the causal structure of a functioning unmasked trial could look like. Talk about that.
All right. So let's focus on A here for a second. At first, It looks like a lot, but I think it quickly becomes quite intuitive. The first variable here is A, and this is just a binary variable. It's like a 0 if you get randomized to control and 1 if you get randomized to treatment. That's all A is. Y is the outcome variable of interest. Let's say it's depression 6 months after you receive the treatment to control. Now, before I get into anything else, there's a couple important things to think about. One, A has no arrows pointing into it. Because we're in a randomized trial, there are no causes of A, except for the kind of coin flip, but we're assuming this is truly random. So it doesn't matter how old you are, how rich you are, or how much experience you have with psychedelics. No matter what, the randomization ensures there are no causes of A, which is the power of experiments for causal inference. Now, X here are a bunch of variables that we measure before the start of the trial. So maybe your age, your pre-treatment expectancies, we talked about as hype, socioeconomic status, experience with psychedelics, etc. Right? Everything you bring with you into the trial. Now, X is going to affect your outcome. X will affect everything afterwards, with the one exception of A, which is randomized. So there's a lot of arrows, but the key point about this is just everything in the past can affect everything in the future. It could. We don't know. with the
Yeah.
one exception of A, which is randomized. Which is classic experimentalism. Now, two variables in the middle, or these post-treatment variables we have, is belief, which drug do you think you got, and expectancy, what expectations do you have about how you think the treatment is going to affect you down the line. Maybe B is before E, maybe E is before B. In reality, there's probably a lot of crosstalk, but we can think of at a fixed time point it having this sequence. And everything before B is going to cause B, everything before E is going to cause it. As we'll talk about, we really think that the mediation through expectancies, like in our benevolent alien example, is really the key with dealing with this problem of trying to get psychedelics on an even playing field with the control. The last thing I would say about this DAG is there are these variables Z, which are just variables after the treatment or control is received that might be common causes of B and E, right? So maybe you trip and you get in touch with some alien life form or something, and it tells you some beautiful philosophy, and this influences your expectancies.
Yes.
One example, right? The trip itself, or maybe the therapeutic alliance that follows from your work with a psychologist using these.
I don't want to steal your thunder in this, but as I'm looking at it, it makes the challenge of what people talk about, just saying, what if we just control for or adjust for expectancy? I feel like your DAG is making it clear why this might be a challenge.
Yeah, I think that's right.
It lies on the causal pathway here.
That's exactly right. It lies on the causal pathway between A and Y. And so the only thing that we really have, at least in a classic trial where we're not manipulating expectancy, the only thing we really have control over is A. And so E is a mediator. It's not a confounder of the effect of A on Y. A confounder would be a common cause of A and Y. But A has no causes because it's randomized. Expectancy is something that happens afterwards. It can't cause A. And so, like you're saying, it really clarifies that the problem boils down to this very particular causal mediation problem. And it emphasizes a couple tricky things. One, if we really wanted to know what the effect of expectancy on the outcome is, we wanted to know how much of a psychedelic's effect is mediated through your post-treatment expectancies. Now we need to measure Z and X, all these common, and B, all these common causes of E and Y. Could be tricky, but at least we know what the challenge is, what we're after. And similarly, X, let's say X includes your pre-treatment expectancies, your hype going into the trial. People will sometimes say this is a confounder. This is a confounder of the treatment effects in psychedelics. But X isn't causing A. X is certainly affecting Y. It's certainly affecting your post-treatment expectancies. It's having all sorts of effects, but it's not a confounder itself. So you do want to incorporate it into your statistical analysis, but you have to be very clear about how you incorporate it in. And I think this DAG provides a simplified picture, but the simplifications don't detract from our ability to use this to identify the causes of bias from functional unmasking and the potential solutions to it.
Have you seen anybody adopting this in practice for these trials, or read about any papers where people are starting to think differently about what to do about belief and expectancy?
Yeah, it's a great question. There's some nice statistics papers that have proposed similar ideas. Some of them we build off of, some of them we have ideas that are a bit different, but a lot of them are getting at ideas of how to deal with these post-treatment variables in clinical trial. There's also interest in this in vaccines. One of the co-authors, who's a well-known statistician, causal inference methodologist, has done some prior work on similar ideas for vaccines, because even though it doesn't cause like acute psychoactive effects, you can encounter similar problems. Folks in the past have focused more on belief, on blinding itself. And I think that's natural, given a lot of the applications that motivated those methodological papers. But I think one thing that I like a lot about the psychedelic case is some of the clever experimental designs that people employ to deal with the blinding problem beg a lot of questions about people's preoccupation with belief itself rather than expectancy. For example, dose-response studies or deep blinding. Deep blinding describes these designs that people use a lot, where you come into the lab, you're told you're engaging in some clinical trial, you have no idea what it's for, and they say you're going to get one of these drugs, and it's got like 15 drugs on it. THC, LSD, psilocybin, ecstasy, ketamine. You have no idea what you're going to get. In reality, you're just getting randomized to one of two, but you have no idea what to expect. So the idea that you could probably you are going to achieve good blinding here. You're going to trick people. They're not going to know what they get. Right. But not all active comparators are created equal, right? Some active comparators, like we talked about before, could be very dysphoric or unpleasant. They may make you hallucinate, but other ones may be very euphoric and manipulate your expectancies in ways that make it feel like the psychedelic and the active comparator aren't on even playing fields for the sake of kind of testing treatment efficacy or therapeutic benefits. So I think that one of the nice things about working with this particular application is it clarifies really what the causal inference folks should be really targeting more broadly in other fields.
I really love examples like this where a DAG clarifies the picture. It doesn't solve the problem. It doesn't do the analysis for you, but it makes the assumptions clear and transparent. I still find a lot of people are reluctant or resistant to use a DAG, but here you're taking what I think is a mistake in the analysis just by simply adjusting for or controlling for something like belief or expectancy. But your DAG makes it clear that you're probably going to make the problem worse because of collider bias. Another win for DAGs.
I think that's right.
You work at the NIH. What's your background coming to causal inference and using DAGs and for doing work like this?
I came from a very subject matter background initially. I was very interested in chemical dependence, neuroscience, neuropharmacology, and I spent college and 5 years after college working in experimental sciences and public health. I spent a lot of time in neuroscience laboratories, running experiments with an interest towards neuropharmacology, again, drug addiction and reward and learning. And I also spent a solid 2.5 years abroad, mostly in Nepal and South America, studying treatments for drug addiction. I did qualitative research. I did some kind of classic public health survey-based research, again, primarily focused on addiction. And I actually spent a full year. I was fortunate to receive this fellowship called the Thomas J. Watson Fellowship. It's through IBM, and it funds people for a year to travel alone with minimal contact with friends and family and pursue a project of interest that you wouldn't be able to do in the US. And I spent a long time in South America and a bit in Southeast Asia at treatment centers where they were using things like ayahuasca, ibogaine, meditation, just general altered states of consciousness, but particularly psychedelics to treat addiction. And I spent months and months at these places interviewing people, doing just pure qualitative research. And then I was fortunate to receive a Fulbright in Nepal where I did more kind of classic public health work on infectious disease among injection drug users. That was more kind of classic treatment, following people in treatment and out of treatment and measuring kind of risk for hepatitis C and HIV. I spent a few years at the NIH doing that lab research. So I really was, up until I was 28 when I joined grad school, very much fancied myself a scientist first, a subject matter person first.
Just to get this right, people think about their own pathways and careers that are listening. Undergraduate, I'm imagining lab-based neuroscience, but then you picked up a public health toolkit, right? Doing more qualitative work that your lab folks don't often pick that up. So that's quite interesting to me. Survey-based tools, again, lab folks often don't have exposure to that. So you really have built, before you got to the NIH, quite a diversity of methods and backgrounds.
Thanks for saying that. I love science. I think there's a lot of these questions are just tricky for all fields. And it felt fun to really engage with different perspectives on it. I was also really interested in drug policy. I did a bunch of research at my college on how their college policies, like big surveys on college policies, how it was affecting drinking and drug use. It was all focused around the subject matter question. But I guess there was itches I wasn't feeling scratched by different fields. They all had their different strengths. And I think when I got to the NIH and was doing more lab research, there was a lot of work with mice and measuring brain chemicals, and it was much more classic behavioral neuroscience, neuropharmacology. The field just seemed like it was really moving in a more computational direction. People were able to measure the activity of many more neurons at once. They were measuring behavior in more complicated ways, like with video, and the analyses seemed like they increasingly became the bottleneck. What types of questions do we even really want to answer? If we could measure every neuron at every second in the brain, what are we going to do with this? It seemed like some of the classic statistical tools or summaries weren't going to be enough. and the field was starting to adopt more machine learning and sophisticated statistics. I also always liked statistical analyses, I think. I'm sure you can relate. You spend enough time doing these projects and you spend a lot of your time dealing with tricky statistical problems in your data sets.
True.
I wanted to get formal training in that. I always liked math, but I was really very neuroscience and liberal arts focused in college. And so I just started taking night classes after lab to just fill in a couple extra math courses I didn't have for biostatistics training. And then, the rest is history. I went to grad school in biostatistics, got my PhD in it, and fell in love with statistical methods research and machine learning and optimization and more classic mathematical sciences methods research. But I still was very interested in using these tools to help further the science. And I love methods research, but I think it's much richer for me when it's combined with real scientific problems. And like this example, it also can drive changes in methodology or conceptualization because the scientific problems make you think about the methods in a different way, like with deep blinding and some of the psychedelic challenges. So I still felt a lot of my qualitative and quantitative research, particularly the stuff I did on psychedelics, like, and this was back in 2012, 2013, I didn't feel personally like my answers about, even after that whole year interviewing countless people in different languages, different cultures, different types of treatments, I didn't feel like I knew the answer to whether these things helped. Maybe that's just my personality or my biases, but I felt like at the end of the day, you get a lot of richness from those types of tools, qualitative research, interviews, but there were fundamental kind of questions about causality that I wanted answered. And so I always had it in the back of my mind, and 13-ish years later or something, I started reading about in the news about all these functional unmasking challenges that led the FDA to ultimately reject ecstasy MDMA for the treatment of PTSD among veterans. And I thought, they're arguing about causal problems, and I'm involved in causal methods research now. This is a great place to chime in. And so I got some other statistician friends of mine together and some psychedelic researchers at Hopkins. And I said, maybe we could put our heads together and come up with a proposal for how to deal with this. And that's how we landed on this problem.
I love it. As early career trainees, you see a linear path that you need to go on. And from my experience, folks like you, yours is a great example of this. Your path is very challenge dependent on learning and discovering what you could answer, what you couldn't answer. And everything in your toolkit at the time wasn't sufficient to get a good answer to this question. And that's like what a scientist does. You went out and you figured out how to equip yourself to be able to answer these questions convincingly. I can't think there's many lab-based, like neuroscience rat folks who have made it to the causal inference domain. Because when you can just randomize and you can randomize rats, your problems aren't as hard as particularly observational studies, but even in these controlled trials where you got to think about how do you adjust for things along the mediation pathway. Causal inference methods are just the right approach for this. That's why your paper stood out to me.
Like you're saying, in a lot of these very experimental sciences, like lab research with rats, you got like genetic twins and you're putting them in one box or another, you're giving them one treatment or another. It feels like the extreme of experimental control. And I think a lot of folks don't often dig into causal inference literature because of that. I have been trying to make the pitch with collaborators on various methods projects that part of the reason why causal inference is so rich is that it really does apply heavily even in highly experimental settings like those. Just had a paper come out where we talked about sequentially randomized experiments, designs like in neuroscience where maybe you're zapping their brain across many replicates or trials, and maybe you're doing it in a way that's behavior dependent, and all sorts of very hard, challenging, tricky causal problems come up. And it seems like you wouldn't need to deal with them because you're randomizing to different groups, to a treatment and control group. But when you dig into the causal literature, you learn about all these very well-known feedback loops and processes, treatment confounder feedback. Talk about it a little bit in the psychedelic paper briefly. And it can really obscure effects. It can really make effects look, a certain kind of treatment effects or causal effects, it can make them look bigger or smaller than the effect you're really interested in. A lot of the clarity around estimands and using more sophisticated causal techniques, it is very important as well, even in these extraordinarily experimental sciences.
It sounds to me like a DAG was your gateway drug to realize all the problems that are out there that need better causal inference methods to tackle them.
It helps a lot with all sorts of science problems, even qualitative research, to really think deeply about what things are we really interested in science and how ought we measure it, what types of experiments or what types of tools. And I think it's a rich area that extends both into very observational, even qualitative research, all the way to these extraordinarily experimental settings, like the lab studies with rats.
Thank you for your paper. I think anybody designing or analyzing these psychedelic trials, it should be required reading to think about the challenges that they're facing. And thanks for talking about your background as well. Quite interesting.
Yeah, thanks for having me, Eric.